Welcome back to the video lecture series on engineering mechanics. Myself, Dr. P. Pramod Kumar, Associate Professor in the Department of Mechanical Engineering at MLR Institute of Technology, Hyderabad. In this video lecture, we are going to study the free body diagrams and problem solving on equilibrium of forces by using free body diagrams. Let us try to understand what is a free body diagram. A free body diagram is a sketch of an object of interest with all the supports stripped away and all the external, internal and reactive forces acting on the body are shown now. This drawing free body diagram is very important in solving the problems from mechanics, especially from equilibrium of forces. It also helps in solving the problems from the unit friction and also dynamics. Let us try to understand the free body diagram. Consider a roller is supported by a vertical wall and it is hanging by means of a string. The string is at an angle theta. Now, let us remove this vertical wall. Let us remove this vertical wall. If the wall is removed, it is not possible to keep the body in this position. Why? Because the string will become vertical and it will attain an equilibrium position. The weight of the body is acting in vertically downward direction, and now if the wall is removed, it is not possible to keep the body in this position. Right? Now the wall is supporting the body to keep it in the position as shown in figure. Here, if we remove the support, we need to replace with equivalent reaction. The weight component or whatever the force which is acting on the wall is supported by the wall. The same amount of reaction it will exert on the body to keep it in this position. That means if we remove the support, we need to replace with equivalent reaction. Then we can keep, by the action of this reaction, by the application of this reaction, we can keep the body in this position. Similarly, if we remove the thread or string, whatever it is, if we remove it, it is not possible to keep the body in this position. That means the string is holding the body in upward direction, So there will be tension in the string. The string is connected to the wall and it is carrying some weight here. So what happens? The string will be under tension. The internal tension will be shown like this. Now I am considering the body, so I will take up to this portion. Right? If we consider the hook, we will take the tension in the string is in downward direction. The string is pulling the hook in downward direction. So here I am considering my point of interest, my object of interest is body. That's why the body is supported in upward direction. The body is held in that position by the tension in the string which is holding it up. That's why the direction is here in the upward direction. Now this is the free body diagram. Now the free body diagram is the diagram which shows only the external forces, internal forces and induced forces and self weights. Here W is the weight of the body which is acting vertically downwards, and a reaction from the wall. The reaction will be always perpendicular to the contact surface. Here the contact surface is vertical, therefore the reaction is horizontal, and the tension induced in the string, it is internal force, self weight, reactions. A free body diagram is a diagram which shows all the forces acting on the body, including support reactions, self-weight, internal forces and external forces. Now, let us draw the force diagram for this. Weight always acts vertically downwards and the reaction is horizontal, and the tension in the string is in upward direction at an angle of theta to the vertical. Right. Now, the given problem diagram is generally known as space diagram or physical diagram or problem diagram, and the diagram which is drawn from the space diagram, which shows only the supports are removed and replaced by equivalent reactions, and the internal, external and self weights all are shown, that is called a free body diagram. And finally, the diagram which shows only forces, is called a force diagram. This is how we need to draw free body diagrams for the given problems. Let us try to understand free body diagrams, how it helps in solving the problems on equilibrium by considering an example problem. Consider the same problem. A circular roller of weight 100 newtons and radius 10 centimeters hangs by a string AB of length 20 centimeters and rests against a wall at C as shown in figure. Now determine the tension in the string and reaction at C, at the contact point. So take the same problem. Now the length of AB is given, the cord length or the string length is given, which is 20 centimeters. The radius BC here, the B is center and C is the outer edge at which the roller is touching the vertical wall. So that is BC is radius. Here in this problem it is 10 centimeters, right? For the same problem, now by using free body diagrams and applying equilibrium concept, find the tension in the string and reaction at C. First, draw the free body diagram. The free body diagram will consist of the force, tension in the string and reaction from C only. The weight always acts vertically downwards and the reaction from the wall is horizontal, which is denoted by R. Here the wall is vertical, reaction will be always perpendicular to the contact surface. So that's why it is horizontal. Now the tension in the string is denoted by T, which is at an angle of theta to the vertical. We'll calculate it. Now draw the force diagram. Force diagram is weight is acting in vertically downwards, reaction is horizontal, and now the tension T is at certain angle to the vertical. Now let us find the unknown forces, that is tension in the string, reaction from the wall at the contact surface. Now first step, calculate the angle at which the tension is acting, because we know the direction of weight which is acting vertically downwards, and we know the direction of R, reaction from the wall at the contact point C, which is horizontal in this case, and we don't know the angle made by T. So let us start the solution by finding theta at which the tension is acting. To calculate theta, I'll take the values or whatever data given in the problem, in the space problem or in the given problem, physical problem, right? So find the angle theta from the triangle ABC. Here we can find the triangle ABC. So AB is the string and C is the contact point and this vertical line. It is a right angle triangle. ABC is a right angle triangle. In the right angle triangle, the angle made by the string, which is nothing but AB, is theta with respect to vertical. with respect to vertical, the angle made by the string is theta. Let us find this theta value by using the triangle properties. Take sin theta. Sin theta is equal to opposite side. Opposite side is BC, which already known to us, which is nothing but our radius 10 centimeters, and divided by hypotenuse AB. Sin theta is equal to opposite side divided by hypotenuse. Hypotenuse AB is length of the cord or string, which is given as 20 centimeters in this problem. Now, sin theta is equal to BC by AB, 10 by 20, which is equal to 0.5. Sin theta is equal to 0.5. Now, calculate theta value. Theta is equal to sin inverse 0.5. Sin inverse 0.5 is 30 degrees. So, theta is 30 degrees. That means the tension in the string is acting at an angle of 30 degrees to the vertical. Right. After knowing the direction, now let us examine the body is under equilibrium by the action of three forces. What are the three forces? The weight 100 newtons is acting vertically downwards. The reaction is horizontal from the wall at C, and the tension in the string is at an angle of 30 degrees to the vertical. By the action of these three forces, the body is under equilibrium. Now, the body is under equilibrium, so we can apply the equations of equilibrium to this body. The equation is sigma h equal to 0. Sum of all horizontal components equal to 0. Here we can find two horizontal forces. One is R, the reaction from wall, which is completely horizontal, and we have horizontal component of tension. Horizontal component of tension in this case is T sin 30. The horizontal component is T sin 30 because T is making an angle of 30 degrees to the vertical. So, vertical component will be cos, T cos 30, and horizontal component will be T sin 30. Now, R is acting towards right side, I am assuming it is positive, and T sin 30 is in the opposite direction to R. So, two forces are there, both are equal and opposite, then only the body will be under equilibrium. Now, let us put the values in this equation. Algebraic sum of all horizontal forces or horizontal components is equal to 0. Now, substitute the values. R minus T sin 30 is equal to 0. R minus T sin 30 is equal to 0, or R is equal to T sin 30. R is equal to T sin 30. Take it as equation number 1. Now, substitute the second equation. Sigma V equal to 0. Sum of all vertical forces equal to 0. The body will be under equilibrium only when sum of all horizontal components equal 0 and sum of all vertical components equal to 0. Here we have two vertical forces. One is 100 newtons acting in the downward direction and vertical component of T. Vertical component of T. The vertical component of T is T cos 30. Horizontal component is, we have already seen, T sin 30. Now, V equal to 0, sum of all vertical components equal 0. That means sum of all vertical components, that is T cos 30, I am assuming positive. So, automatically we can assume that the downward force is minus. Upward force I am taking positive. So, downward force is negative. T cos 30 minus 100 is equal to 0. T cos 30 is equal to 100. From this equation, we can calculate T value, tension in the string. Tension in the string is equal to 100 divided by T cos 30. So, the value of tension in the string is T is equal to 115.47 newtons. 115.47 newtons. Now, substitute the value of T, the tension in the string, in the equation number 1, R is equal to T sin 30 to find the unknown reaction from the wall. So, substitute the value of tension in the string, which we have obtained from this equation, sigma v equals 0, back into the equation number 1, so that we can get the reaction from the volume. So R is equal to 115.47 sine 30 T sine 30. The value of reaction is R equal to 57.735 newtons. In this video, we made attempt to understand what is a free body diagram and how it helps in solving the problems on equilibrium of forces. Thank you.